Hey, Math 8. My plan for today is just to show you a few more problems to kind of review what we went over yesterday and then give you some more time to finish this and some Alex. Your assignments for this week, I posted in the Google Classroom. It's going to be to finish this linear versus nonlinear function assignment on Study Island, and then also to give me a day's worth of Alex. So 5 topics and 45 minutes. So between yesterday, today, and Wednesday, we should be able to handle all of that. So getting started on this problem. Y equals 3x squared plus 7. And if you remember, if we have an equation that can be a line, it needs to match up with y equals mx plus b. So we have the y, we have the equals, we have the m, we have the x, but unfortunately we got this little guy hanging out, this squared. All right, and that squared makes this a non-linear function. And I know I go to the table a lot, so let me kind of show you what happens in the table to show that it's not linear. So if I were to put 0 in there, and let me erase all of this stuff here so we can see. If I were to put 0 in there, x squared, meaning 0 squared is 0 times 3 is 0, we would end up with 7. If I put 1 in there, so 1 squared is 1 times 3 is 3 plus 7 gives me 10. And then if I put 2 in there, this is where we're going to see. So right now we're going up 3 while x increases 1. And we're increasing x again by 1, but y is not going to increase by 3. All right, so if I do 3, and maybe I should have done this for all the other ones so you can see where these numbers are coming from. So what I'm doing is substituting x or 2 in for the x. Following the order of operations, I need to do the exponents first. So 2 squared is 4, and 3 times 4 is 12, and 12 plus 7 is 19. So you see that this actually went up 9 now. All right, so 2 ways we can look at this. We can make a table. Anytime you have an equation, you can make a table and find x's and y's, and notice that the rate of change is different between these different points. Or once again, like we looked at the very beginning, it does not equal y equals mx plus b. There's an exponent on the x, making it non-linear. Okay. Speaking of y equals mx plus b, this matches perfectly to y equals mx plus b. There's no little exponents hanging around. The y's match up. We got the equals. We got the m is the 4. The x is the x. And then 7 is the b. So everything's good. This is a linear example. Graphs, I think, are pretty straightforward. Linear, we talked about the word linear. It means a line. Lines are straight and they go on forever and ever and ever. Neither of these are lines. So neither of them are linear. So when I ask which of the following graphs represents a linear function, this is a neither. Neither graph represents a linear function. Okay. These situations, sometimes these situations are a little harder, but once again, we have to think about, are we going to be changing the same amount every time we increase the x, or the independent variable? So in this case, a soccer manufacturer company spends $5 on each soccer ball. So if you think, if we increase the soccer ball by 1, it goes up $5. Increase by 1 goes up another 5, goes up another 5, goes up another 5. So it's the same over and over and over again. So that is going to be linear. Items at a clothing store sold at a discount of 20% off the original price. So if we look at, let me get a table going here. I love my tables. So in this case, y is going to end up being 20% off. I'm running out of time, so I'm going to pause the video real quick and come back to this spot. Okay, so going back to B. If we talk about something that costs $1, 20% off $1 is getting 20 cents off of $1 or paying 80 cents. So we have 80 cents for that. If you buy something for $2, 20% off is now 40 cents, or we can still talk about $2, so that's $1.60. If I buy something for $3, 3 times 20% is going to be 60 cents off. So now $3 becomes $2.40. And you'll notice every time I am increasing by 0.8 every time that X increases by $1, which is why this is going to be a linear function. C, the number of dogs in a town increases by 20 per neighborhood. All right, so the fact that every neighborhood is going up by 20, that's a linear function. So that leaves us with D. D is going to end up being the nonlinear function. I just want to talk about why. So the number of students enrolling at a high school increases by a factor of 1.25. All right, and if you go way back to when you learned about multiplication problems, you had the product. The product is the answer to a multiplication problem. And the two things that are multiplied, those are called the factors. All right, so this basically says we are multiplying by 1.25. All right, so let me just give you a quick example here. If I take 1 and I multiply it by 1.25, let's not use 1, honestly. That's not a realistic number of students that are enrolling. Let's say that we have 100 people enrolling. All right, so if I have 100 people that are enrolling, and then the next year, that increases by a factor of 1.25, that gives me 125 people. All right, so year 1, we can say there are 100. Year 2, now there's 125, so it went up by 25. But now we have to consider, okay, we're multiplying by 1.25 again, but now we have 125 people. So 125 times 1.25 is now 156.25. So on year 3, it's up to 156.25. And obviously, we would round that to 156 to account for whole people, not a quarter of a student. But if this went up by 25 again, we would be at 150. So it's actually going up by 31. So it's not going up by the same. All right, technically 31.25. So because it's not going up by the same amount every time X increases by 1, it's not linear. All right. I'm just going to keep going until I run out of this 5-minute block here. And then I'll let you guys get to it. A certain type of bacterial cell divides into 2 cells every hour. So basically the population doubles. And this is nonlinear because it's not going to be going up by the same amount every time. So just like we talked about before, in year 1, let's say the population started at 1. And then, or I guess every hour, in hour 1. And then the next hour, it doubles. So it goes up to 2. And in the next hour, it doubles again, goes up to 4. And the next hour, it doubles again, goes up to 8. So you can see between here, it went up 1, then it went up 2, then it went up 4, while X still goes up by 1 each and every time. So when we compare the change in the Y's compared to the change in the X's, they are different, which makes it non-linear. Okay. So clearly with the graph, we can see that that's nonlinear. So I'm going to go ahead and drag that to nonlinear. The equation, so I'm just going after the easy ones right now. The equation, that fits y equals mx plus b. So that one's going to be linear. Now let's investigate the tables a little bit. So here I'm going up by 12 while x is going up by 2. So that rate of change is going to be 6. 18 to 38, that's going up 20 while x is still going up 2. So that rate of change is 10. So that gives me a nonlinear example here. And then the next one, the x's are going up by 2s while the y's keep going up by 4s. So that will end up being... So I definitely lied when I said I was just going to be done when the 5 minutes ended. The next couple questions were the same as we've done before, but this one I noticed it's got a little different wording that we haven't really talked about specifically, but I want to point out this, and we only have one after this, so we might as well just go for it. Constant means it stays the same. And that's what we've been looking at with those tables where we have mentioned, okay, as x goes up by ones, the y's, all right, so let's go 5, let's say the y's are going up by 2's each time. So that rate of change is going to be 2 for the first point. It's going to be 2, it's going to be 2 as the x's are going up by ones. I know it's a little sloppy, but hopefully you get the idea. So we have 2 over 1, the y's over the x's. And then we have 2 over 1 again. And then we have 2 over 1 again. So that's what it means by constant. Constant means it doesn't change. It's always going to be 2 over 1. And we talked about also, what if we just looked at the two endpoints? All right, so if we went from 5 to 11, that's going up by 6. And 1 to 4 is going up by 3. Well, guess what 6 over 3 simplifies to? 2 over 1. So it's still going to be the same. So what I want to point out here is constant rate of change means the rate of change stays the same between all of the points. And all of this was to describe linear functions. So that means x is the one that is going to have the constant rate of change because it is a line. And graph W does not. All right, so let's go ahead and hit this last problem up real quick. All right, so the formula for the area of a square, where the side length is the independent variable and the area is the dependent variable, is a nonlinear function. All right, so here's kind of what they're talking about. The area of a square, you take the side, which I'm going to call x, and you square it. And if we remember, for it to be a line, we should be able to do y equals mx plus b. And we're not doing that in this case. All right, technically the b is 0, the m would be 1, but because we have this exponent here, it makes it non-linear. So it's going to be non-linear because the points do not lie on a straight line. All right, now the formula for the perimeter of the square. So we did area. Now if we look at perimeter, all right, to find the perimeter of a square, let's say every side is x because every side is going to be the same length. And to find the perimeter, that's the distance around. So I would just take x plus x plus x plus x, or since there are 4 x's, we can just say the perimeter equals 4x. And if we consider that and align that up with y equals mx plus b, that one works. All right, so because there is no b, we can just assume it's 0, but we have y equals mx plus b. So that means that one is a linear function because the points will lie on a straight line. Okay, so now for real, that's it because this is question 10. We are done with this assignment. So hopefully that helped clear a few things up. I know repetition is always a good thing when you're looking at math. So your goal now is to finish this linear versus nonlinear functions. And once again, 1 day of Alex time and topic goals, so 45 minutes. 45 minutes and 5 topics. All right, and I should be back tomorrow to have a little bit of fun in math class. See ya.